So, firstly, we want to find xc and yc. We can do this in two quick steps firstly. First, split the cross-section into two segments and then find the centroid of each one. We know that the centroid, centre of gravity, is going to act at the geometrical centre of each shape. So here, let's draw this on and call it G1 for shape 1, and same here, G2. And then we need to draw two reference axes. This one's going to be x prime, and this one's going to be y prime. Now we can find xc and yc. So, to find xc, we multiply the area of the first block by the distance from G1 to the y prime reference axis, then add up the area of the second block and multiply the distance from G2 to y prime, and then divide everything by the total area, so the sum of these two blocks. So, xc is, for shape 1, 20 times 60 is the area, and then 30 is the distance from G1 to y prime, because it's from here to here, which is 30. Then we add, for the second block, the area, which is 100 times by 20, multiplied by the distance from G2 to y prime, which is half of this, so half of 100, so 50. Divide by the total area of the two blocks, so the area of G1, 20 times 60, plus the area of the second block, 100 times by 20. And this is going to give us 42.5 millimeters. All units are in millimeters. Now we can find yc. So, once again, the area of the first block, but this time we multiply by the distance from G1 to the x prime reference axis, not to the y prime. And then we add the area of this block, multiplied by the distance from G2 to the x prime reference axis instead of to the y prime. Yeah? So, the area of block 1 is 20 times by 60 times by this length. What's this going to be? So, from G1 to the top of the block, we know it's 30, half of 60. And then we need to add this distance, which we know is 20. So 30 plus 20, 50 is the total distance, times by 50. Plus the area of the second block, which is 100 times by 20, multiplied by the distance from G2 to the x prime reference axis. This is going to be half of 20, so 10. And then divide by the total area, which is the same as above. And this is going to give us 25 millimeters. Now we can replace them in here, the values we have. So x prime is 42.5. And y prime is 25. And we can get rid of this, because now we are going to take second moments of area about the x-axis of all these segments and sum them up to find basically ixx. And then we repeat to find iyy with the y-axis. So let's use purple. When we're finding ixx, we're going to use this Roth formula. So base times height cubed over 12 plus the area of the segment multiplied by the distance between G and G1 in this case, or G2, whichever G we're using, squared. So to find ixx, first we need to find ixx1 and then ixx2 and sum them up. So for shape 1, we know that the base is 20 millimeters times by the height of 60, which is cubed, divided by 12, plus the area 20 times 60, plus times by the distance squared between G and G1. So what's the distance from G to G1? This one. So how do we find this one? We're going to subtract from the total distance of 80 this distance and this distance. This one we know is 25, and this one we know is half of 60, so 30. So we do 80 minus 25 minus 30 to give us this distance, and that's going to be 25. Now it's going to be minus 25 though, because looking at the actual center of gravity here, to go to G1, we're going down, it's below, so it's negative, we have to refer to it as. Although we're going to square it, so it's going to cancel out and be positive, but it's good to write it down in case further examples require that. And then to find ix2, same thing with the top shape. So the base is 100 multiplied by the height cubed, which is 20, divided by 12, add the area of 100 times 20, and multiply by the distance from G2 to the actual G. So from G2 to this one. This one. So we know that the total distance from the x prime axis to G is 25, and the distance from the x prime axis to G2 is 10. So we do 25 minus 10 to get this one, because this one's 10. This one's 25. So this one is 15. Multiply by 15 squared. This time it's positive because looking at G, to go to G2, we're going upwards in the positive direction. And we square that, and it's going to give us 5.17 times 10 to the power of 5. And this one was 1.11 times 10 to the power of 6. Now, to find Ixx, we said we have to add up Ixx1 and Ixx2. So these ones. And when we add them up, they're going to give us 1.63 times 10 to the power of 6 millimeters. That's Ixx. Now, we need to find Iyy. This time, when we're finding Iyy, there's going to be a change here. It's going to be base cubed times height over 12, which in this case, we're going to write to make it neater as HB cubed over 12. And then add the area multiplied by the distance from G to G1 squared. Although another thing that's different this time here is we're no longer going to find the distance to the vertical axis, so vertically to the x prime axis. We're going to multiply by the distance to the y prime axis when finding Iyy. So by this one, the distance from G1 to the actual centroid, like this, instead of like this. So instead of like this, like this. This one's like really small. Okay, so let's find Iyy. We're going to start with Iyy1. So for shape 1, height, which is 60, times my base, which is 20, cubed divided by 12, plus the area of 60 times 20 multiplied by the distance between G1 and G2, which in this case is from here to here. So we know that from the center of gravity to the y prime reference axis, the distance is 42.5, and that from G1 to the y prime reference axis, the distance is 30. So we do 42.5 minus 30 to give us this one. So 42.5 minus 30, we have 12.5. Is it positive or negative? Looking at the center of gravity to go to G1, it's in the negative direction. So it's negative 12.5 squared. And this is going to give us 2.28 times 10 to the power of 5. Now to find Iyy for the second block, we have the height 20 multiplied by the base length 100, which is going to be cubed and divided by 12. So 20 times by 100 cubed over 12 plus the area of 20 times 100 multiplied by the distance from G to G22. Let's zoom in a bit. So from here to here. Now, once again, we know that from G2 to the y prime reference axis, the distance is going to be 50, half of the total length. And from G to the y prime reference axis, 42.5. So now we do 50 minus 42.5, and that's going to give us 7.5, the distance between the two. Now, from G to G2 is going in the positive direction, so it's plus 7.5. Let me plug this in the calculator. 20 times 100 cubed divided by 12 plus 20 times 100 times by 7.5 squared we have 1.78 times 10 to the power of 1, 2, 3, 4, 5, 6. 10 to the power of 6. Now to find I, Y, Y, we add these two up. So that plus 2.28 times 10 to the power of 5 plus equals 2 times 10 to the power of 1, 2, 3, 4, 5, 6. And that's IYY.